Today we have a quick video. We're going to be looking at some specialized registers and counters. Early on in the book, Digital Electronics with Arduino, we cover shift registers, and we also look at counters using JK flip-flops. And this is, I think it's in Chapter 8, we're going to be looking today at something that's a little bit odd. It's called a ring counter, R-I-N-G, ring, like a circular ring. And what it'll do is when you put a high on one of the flip-flops, you can clock it so that it goes around the ring of all of the remaining flip-flops. We have two chips, two ICs, so there's dual flip-flops, so that's 4 flip-flops total, and it'll light up an LED every time it goes around to a new position in the ring. You'll see it circulate. We have the LEDs in a row. We're using the digital analog trainer, but it could just as easily be set up on a board in a circular pattern. That's the first one, the ring counter. Then the second one is a twisted ring counter, and it's a little odd. In class, the question came up, well, where do you use these? And the answer is for the, for the regular ring counter. That could be used in an application for like multiplexing, or anytime you wanted to enable a specific line. It could actually be clocked by a 555 or something like that as a project. But the other one, the twisted ring counter, I had people look into that. Some of the students found that that was used for, of all things, encryption. So we don't want to talk about that. Even if I knew what that was all about, I wouldn't tell you because it's secret. But we'll take a look at this. We'll see how the two counters work on our breadboard. The schematic of the ring counter is pretty basic. It's just going to connect all of the Q outputs with the D inputs, except the last one, the one over here toward the right, is going to go all the way back to the initial D input. So that's your ring counter. It's going to circulate over and over. And the breadboard circuit that we have hooked up over here, let's fire this thing up and give it a shot here. We could start off by clearing it, and it just so happens that we are cleared right now. All of the LEDs are off, and again we're using the trainer, but you could very easily just interface some LEDs and hook them up to the Q outputs, and you would see what we're doing here. The clock, I'm going to do it manually, but that would be nice to hook up to a 555 circuit or some type of a function generator that puts out a TTL level pulse periodically, so you can hook it up at maybe a couple of hertz and get it to just keep going around and around, but I'm going to do it manually. So first off, though, I'll set the first flip-flop. So when I go ahead and asynchronously, I'm going to set, and then I go back to the inactive state. So I've set a 1 into the first flip-flop. Now as I clock, I'm going to go ahead and pulse the clock. When I clock it, it goes to the second flip-flop, goes to the third flip-flop, goes to the fourth flip-flop, and here's the trick. It goes back and starts all over again. So that is the regular ring counter. It'll just keep circulating like that all day long as that clock pulse is there to move it through the series of flip-flops. Now the next one, we're going to go ahead and let's see if I could get in here and kind of switch things around. I'm going to go from the output, the very output, the last one, Q, and I'm going to go to, hopefully I have it right without my glasses. It's a little hard to see, but I think I'm on the not Q. So if I start clocking it now, what happens? Oh boy, look at that. All right, they all light up, and then they're all going to go out. And back to all lighting up, and then all going out. So that's kind of an odd situation. That's the twisted ring counter, also called a Johnson counter. So there we have it. We had some specialized counters, and like we said, the first one, the ring counter, has a lot of options, that you could use it for. And the twisted ring counter, the Johnson counter, we're going to keep that one a secret.